Hey guys, Mr. Veve. This is Unit 2, Module 7, Fission and Fusion. Here we go. So, we're going to start off by talking about nuclear reactions, and they're all based on Einstein's theory of relativity here. So, his famous theory, and he talks about how at speeds approaching the speed of light, energy and mass become interchangeable. And we've all seen this equation before in one way or another, E equals mc squared. That is, energy equals mass times the square of the speed of light. And so what this means is that mass can be converted to energy and vice versa. So this brings us to what this concept we're going to talk about, which is called mass defect. So when you have an atom and you have all the parts that make up an atom, we know protons, neutrons, electrons. If we added all of the parts of an atom together and then we actually massed out the whole atom, there is a difference. So the difference between the mass of an atom and the various particles that make up an atom is what we call the mass defect. Okay? And that mass defect is actually the binding energy of the atom. So the defect that we find is actually the energy or the glue that is actually holding all of those particles together. So in nuclear reactions, the binding energy is what's actually released as energy, heat, light, or radiation. And actually that has a measurable mass sometimes in the form of a particle. So the types of nuclear reactions that we're going to talk about, we have fission, fusion, and radioactive decay. Radioactive decay we're going to get to next module, so for now we're just going to talk about fission and fusion. So let's look at those in a little bit more detail. So fission is the splitting of a nucleus into smaller nuclei when the nucleus is struck by a neutron that has enough energy. So when the splitting of this nucleus happens, there's a lot of energy released. We can actually control fission reactions right now in our nuclear power plants that you see around the country. And it's actually a pretty clean source of energy with no carbon footprint. The only issue is that it produces tremendous amounts of radioactive waste, and there are definitely some long-term environmental and health considerations there. So fission, clean, but the waste is actually kind of dirty. So here's a picture of the fission process. We've got a neutron, if you see on the right-hand side, that is hitting a uranium-235 nucleus, causing it to increase in mass by 1, because a neutron has a mass of 1. Comes 236 uranium, and that actually then splits up into two smaller nuclei, as you can see there. You can see a tremendous release of energy, and there's actually 3 more neutrons that are released from that that could actually go on themselves to spawn more fission reactions. And you see the actual equation written down there below. Fission and nuclear reactors. Here's a picture of a nuclear reactor and how it all plays out and how it works. It's all very confusing, so if you're really interested, you can go talk to Mr. Harding, and I'm sure he'll be happy to explain how all of it works. So here we are with fusion. Fusion is the opposite of fission. You have lighter nuclei that actually fuse together to make a heavier nucleus. So this has a huge release of energy, tremendous release of energy. And here's an example of a fusion reaction. So you have heavy hydrogens, deuterium and tritium, which are hydrogens that have more neutrons than normal, and they will fuse together to form a helium nucleus and an extra neutron and a boatload of energy. So this is what actually powers Sun and all the other stars, these types of fusion reactions. We have not actually figured out how to maintain a stable fusion reaction that we can create, but if we could, that would be tremendous. So I hope one of you guys can do that one day. Here's the fusion process. We've got deuterium and tritium on the left going in, forming a huge amount of energy, and you form a helium nucleus, neutron, plus a lot of energy being released. Here's a little table detailing fission and fusion. So we've got fission as the breaking apart of a nucleus, and fusion is 2 nuclei coming together to make 1 nucleus. On the right-hand side, the third one down, fusion, it should say releases more energy than fission, not fusion releases more energy than fusion. So just a little correction there. Here are your key terms. There's only a few of them. We'll see you next module.